It's really nice to be here. Thank you for having me for today's session. I hope you guys are enjoying your time at this International Economics Olympiad. I hope this lecture will be useful for you in your future endeavors. So today we're going to talk about the data science and economics, precisely what can and cannot economists do with data science, and how they can take advantage of the recent trends that are being observed over the whole world, right? So my name is Gaziz Seilkhanov. I'm, as Asel said, I'm currently the advisor to the chairman of the board at Economic Research Institute. This is a think tank that works closely with the government of Kazakhstan. And we are engaged in a lot of work in economic policy making of the government of Kazakhstan, and we are regularly issuing papers, doing some academic research as well for universities, so on and so forth. So pretty much we're engaged with literally all stakeholders in Kazakhstan and in the region of Central Asia, and we're very much engaged in the work using the data science as well. I studied at Boston University and Harvard, so whoever has questions on how to pursue their academic career further on in these universities can also reach out to me, and I can consult you if that's what you want. So let's start. First and foremost, let's define who is data scientist and what is data science has to do with in the economic profession. So first of all, if you asked me 10 years ago, for instance, would you be able to do some analytical work using some data science techniques in your profession? I would say no way, because back then, machine learning, deep learning, data science tools were not so developed as they are now. But you see, Hal Varin, I'm not sure if you know him, but he is a very prominent economist who used to be a professor at several universities, including Harvard. And he wrote this very interesting, very popular microeconomics textbook for graduate level studies at American universities. So he said, he's currently a chief economist at Google. He said the sexiest job in the next 10 years will be statistician. The ability to take data, to be able to understand it, to process it, to extract value from it, to visualize it, to communicate it. That's going to be a hugely important skill. Well, first and foremost, Hal Varin himself is an economist. He's not a statistician. But then he said that the future belongs to these guys, right? He is partly right and partly wrong. Why? Because statisticians themselves are very limited. Of course, they are very strong. They have very strong technical skills, but being just a statistician is not enough, right? It's the necessary condition, but not sufficient condition. When we talk about data science is just an analytics is the field which aids in making informed decisions by aggregating statistical and mathematical tools with expert and contextual business acumen, right? So basically what a data scientists do is, as you can see from the slide, is all these four exercises, right? First is data acquisition, then data management and transformation, computation and reporting and visualization. When we talk about data acquisition, it's pretty straightforward, right? So you will want to communicate with the statistics offices, all these data survey analysts, gatherers, so on and so forth. So data acquisition is pretty straightforward. But when you deal with data sets, databases that you've collected, you will want to clean the data. You will want to work on the data so that they are workable, that they are eligible for further analysis, modeling, so on and so forth. Because why? Because usually when you collect the data are very dirty in a sense. Sometimes they have overestimations. So you will see outliers, very unusually high values for a certain variable, and so on and so forth, or very low value likewise. Also, there are a lot of problems. You frequently will encounter such problems as missing observations, because especially that's specific to survey analysis. When you talk to businesses, when you talk to people, when you ask questions and fill out the survey forms, most of the time you will encounter such problems as they refuse to answer certain questions, or maybe some questions are very sensitive and they are not allowed to share the data, so on and so forth. So basically, this is a huge task, and the technical capacity in dealing with the data and data architecture is very critical here. And then a very interesting job comes in: computation. Once you have the data set, you will, as a data scientist, you will develop models, both economic and statistical models. You will, create, work on identifying patterns, correlations, so on, so causality, so on and so forth. So basically, computation stage of this process is very interesting. And last but not least is the reporting and visualization. Having these skills of, and creativity to a great extent on properly report and prepare very interesting visualization tools will work for the benefit of you if you are, also a, proficient in delivering the data. What does the labor market looks like for data scientists? Recent surveys have shown that data science is a very attractive profession. You can see from the median annual compensation by job title for United States data professionals, you see that when you compare it to other professions, data scientists are very highly paid. For instance, it's a very skilled job, first of all, of course, but they're also in very high demand. When you look at this distribution of salaries, you'll see that machine learning engineers, data scientists, software developers are the one who enjoy the highest salaries, and that is compared to average median salary of $40,000 to $50,000 to $60,000 per year in the United States for the overall labor market, right? So twice as much. Of course, when you talk about data science, you have to come with certain skills, technical skills like programming skills, familiarity with certain software. So these are on the left side. You'll see the chart that shows what skills are required of data scientists and economists. First of all, when you enter such kind of positions at companies, right? So, of course, obviously, the highest, the most popular skills required are the Python, SQL, Java, R, and so on and so forth. So these are the programming languages that you actually must have to enter the job market, to grant a position, right? When we talk about salaries, you see these charts and these graphs, these tables, sorry, and you'll see that whenever your skills, whenever you increase your academic level, you of course have a higher salary range offered at companies, right? So, for instance, the median salary for a master's level, for instance, if you want to participate to advance to graduate studies, is ranging from $60,000 to $70,000 per annum. When we talk about sectors, you will see that the highest paying jobs are in the telecom and tech sector, which show the on average higher than the overall median. For the overall median, right? So, for instance, when you apply for a tech company like Google or Amazon or Microsoft or Apple, you will expect to receive more than $90,000 per annum. So these actually, the labor market is pretty hot here. So basically, when you decide to switch from an economist position to a data scientist career, you will encounter much higher salaries for yourself. But what skills do economists? So what economists are differentiated among every other people that are employed in data science? As you know, most corporations employ data science from different from different fields, which range from economists, computer scientists, even Amazon and Google and Microsoft even hire physicists and mathematicians for these roles. But what economists are prominent for in the data science, and what advantages do they have? First of all, is that we understand objective functions. What do we mean by objective functions? The nature of economics programs in universities is that, you know, I'm talking about very top level schools, right? So when you enter these schools, you will encounter a very huge amount of mathematics in the whole program of economics, right? So you will start with linear algebra, calculus, and then proceed with probability theory, optimization, differential equations, so on and so forth. Some programs even offer topology classes, right? So when you encounter economics further on, when you study microeconomics and macroeconomics, you will always have this optimization problem to solve for, right? So for instance, firms, when we talk about firms at micro level, all they do is, all their objective is just to maximize profits, right? So in this case, you will build up economic models, you know, and apply mathematical tools in optimization tools precisely in order to solve this particular problem. And economists, having spent all these academic years solving these issues, are well aware of the objective functions that are required of you when you enter data scientist role, right? And in most cases, academic answers might not be the best answer. For instance, when you go to a statistics program or pure mathematics program, you are solving the extreme, the local or global extremum, right? For instance, but when you talk from the economist perspective, you are not, you know, since economics is a social science, you're not bound to a certain level, certain correct answer, right? You can actually be free to deviate from the ideal world to a certain extent. For instance, when you have a task to, for instance, when you run a certain statistical exercise and you see that a certain pattern explains your model explains a certain natural phenomenon at 95% of the time, you'll see that, okay, this 95% of the time is very sufficient, and and you can accept that hypothesis, for instance. So these kind of things are what economists are more, are beneficial in terms of entering to the role as compared to other professions. The second thing that economists are differentiated for is that economists graduating from these programs are from regular undergraduate economics programs are very strong at regression analysis, right? So for instance, when you pass these econometrics courses in your undergraduate programs and graduate programs as well, you will have a better picture in linear regression. For instance, via ordinary least squares. This is the procedure that you will first and foremost be familiar with. So having passed these courses and having acquainted yourself with this regression toolkit, you will be able to build a better model than others who do not actually see certain assumptions, or who are actually very strict to certain assumptions. So economics programs are very, very useful in the sense that they allow you to, to lift certain assumptions in a very appropriate mathematical way. And also economists are very, very, very focused on data generating process. Why? Because certain observations, when you do your job as a data scientist, you'll encounter the problem of how data are generated. So you can actually clean the data more properly, more appropriately as compared to other people, because you might have a better picture in understanding how the data are being generated. Also, what makes us very comparatively advantageous is that we own observational data and causality. Economists basically are trained in causality and are interested, if not obsessed with, the data generating process, as I said previously, right? So the data represents actors in the economy who behave in their own interest and are under constraints, and economists are especially well trained to make sense of the underlying behavior leading to the particular collection of data, right? So questions like why a consumer makes a purchase or not, why an investor, for instance, decides to buy a property or invest in an instrument, why a worker leaves a job, or why one unemployed refuses an offer or of employment, or are all, so these kind of questions are all the purview of the economist. Data represents the observations on purchases, for instance, but they come about because of the human behavior economics is able to model. A statistical model, for instance, on the contrary, is not an economic model. Statistical significance is a necessary condition, for instance, but not a sufficient condition for economic significance. So the economist does use a statistical model, but the econometrician uses it in context with causality and the data generating process. Overall, when you compare a statistician or mathematician or physicist or any other profession with an economist, you will see that we want more, right? We want the nature of the data. So just to remind you of the data generating process. Another skill that that differentiates economists is that we are able to tell a story, right? The economists are very good storytellers. Asking why and not just accepting facts as stated or statistically revealed is a type of occupational hazard for economists and a good one for employers. One of the former CIOs, chief investment officers, and one hedge fund, as I spoke to, expressed excitement that economists understood causality and the data generating process, as his experience was most analysts do not. Knowing that data has revealed a correlation or trend, as one might find in a statistical analysis, does not explain why the correlation or trend exists, right? So it also does not necessarily allow itself to be subject to other influences that may matter and that are not examined unless one is asking the why question. So, these questions originate at the concept of agent, right? So we want to understand who are the agents we are dealing with, right? By agents, I mean your counterparts for a company would be competitors, your clients, your customers, your investors, your partners, so on and so forth. For a macroeconomist, when you're talking about the overall macroeconomic analysis, you will encounter such variables, such agents as households, firms, governments, so on and so forth, other countries versus your own country, so on and so forth. And the objective always is growth, for instance, for macroeconomists. For firms, it would be maximization of profits, so on and so forth. And of course, constraints, budget constraints, when you talk about monetary policy for central banks, it would be the zero lower bound, for instance, as observed lately in the last 2 crises. So these kind of things, storytelling is very important and what distinguishes economists from other professions. Additionally, the data is typically never clean, as might be experimental data or results of a quality control investigation. In fact, economists have to learn to deal with data that is observational and subject to all sorts of dirtying influences. And so in this case also, you will as an economist, you will have a better picture of explaining why the data behave like they are doing, right? So also, we work with big data. Big data, by meaning big data, I'm not focusing on your attention on images or movies or sounds or so on and so forth, but by big data, I mean data that exceed the size. In other words, the rows and columns and formats of the data, which is comfortable to work with. So growing problem with data hoarding practices is a very huge problem recently in the whole world for most corporations and governments, and the ability to work with such data is very important and something that economists are valued for. What else? Technology barriers to entry for economists have certainly faced some barriers to entry into the field, and in some cases these things that I'm going to explain right now here are the strengths of others, like computer sciences. But this is something that most programs in the world are not offering. I'm not talking about the top level programs in the United States, such as Harvard and MIT, but most programs like my program when I did my undergraduate 10 years ago, we did not have so much exposure to computer science and programming as most programs are now. And this is a challenge for people like us, right? So in data acquisition, for instance, as I mentioned before, these 4 stages of work that a data scientist do, they use different tools. And for data acquisition, for instance, the first stage, the familiarity with SQL, Hadoop, Python, API, so on. So these are the things that are required of when you do data acquisition. Data management transformation requires SAS, SQL, Hadoop, and I'm just outlining here the most popular software and programming languages, but it's not an exclusive, and it's not an you know, it's not so these are the most popular. I'm not restraining the list with particularly these programs, right? So when you talk any further on in the data scientist job, you will also encounter the whole data analysis process. You will encounter some other languages like R, Stata, and Tableau, which are, for instance, the Tableau is best at visualizing the data, building very interactive and beautiful charts, graphs, so on and so forth. So these skills are something that required of in most current vacancies, job openings that you will have to get a note for. Currently, what academics can do and students also can do in getting yourself prepared for positions like that is require additional statistical or business statistics courses focusing on data visualization, so that you can be aware of some techniques and tools that will be useful for you when you enter the job market. Also, you will need to adopt departmental tools and ask for training from vendors. For instance, most consulting firms also offer courses at universities in their own software. For instance, Stata, SAS, or MATLAB offers their own courses, and at some certain schools you can also attend those classes as well. And also find local employers while you're in school. You can actually apply for internships, and that would actually give you a sense of what's the working environment in some firms and corporations, and also help. You might be you might apply as a research assistant in your own school for a professor who is running a research of his own. So these are the things that I wanted to mention today. So thank you for your time, and I hope I was very clear with things that I wanted to mention. And if you have questions, please I kindly ask you to ask them. Thank you.
Gaziz, thank you very much for this interesting presentation. We have a couple of questions. So the first
Right.
question is, what is the difference between data scientists and data analysts and statisticians?
Sure. Let me refer back to this page. Data scientist, as I mentioned, copes or deals with all these 4 stages of data analysis process, right? So when you talk about a data scientist is not only able to work with the data, clean it, organize it, operate it, but also he is able to generate models, create some not only economic but financial, medical, biotech, any sort of a model that can get use of this data, right? So you can actually create theories, build hypotheses, and test those hypotheses. So this is what differentiates data scientists from the rest of the people, right? So data analysts, first and foremost, is a person who actually works with the data itself. And he collects the data, he builds up the database, he deals with the whole data architecture. He or she also cleans the data, works with unusual patterns in the data. So data analyst, basically a person who works with the data itself. He or she also is able to generate some models, but those models are usually very simplistic. Machine learning engineers, deep learning engineers are not data analysts. They're more than that. Data analysts do not involve in econometric modeling, so on and so forth. So basically, data analyst is the one who works closely with the data. When you talk about data visualization, business analysts, BI analytics are the people who work with visualization. So these are this is something that they are most, the strongest for, right? So building up very quickly building up interesting and engaging charts and interactive graphs, so on and so forth. So this is something that business intelligence units are very strong for.
Thank you very much. We have another couple of questions. So sure. What should be the starting point for an economics graduate for data science learning?
I'm sorry, again, can you repeat again?
Mm-hmm. Yeah, sure. What should be the starting point for an economics graduate for data science learning?
Starting point, so it depends on the program that particular person is studying at, right? So if you are on a graduate or graduate program, has some mathematical exposure, use more of that, right? So if not, you'll have to get acquainted yourself with econometrics, right? So if you are familiar with some statistical modeling, try to proceed with econometric modeling. Try acquainting yourself with regression analysis. So there are a lot of literature over there in the internet that that you can use in order to study econometrics, right? This is something that econometrics basically is 80% of the job in data science, right? So building up the appropriate model that explains correctly the nature, the observation, the phenomenon that you are working on, whether it is a sales or marketing sales, biotech engineering, building up a certain good or service in production. So these things are very dependent on econometric modeling. So when you want to start break into data science, you'll have to first and foremost study econometrics. And of course, this comes along with studying programming skills. So also you'll have to start programming at certain point in time. And my advice for you would be at this point in time to start with Python, as it is the very simple and, well, actually it's the simplest programming language with no hard syntaxes, so on and so forth. So it's very easy to start with, and you can actually, once you comprehend the Python language, you can actually further go on studying C, C++, Java, so on and so forth. So basically start with these two things, econometrics and programming.
Thank you. I hope the speaker answered your questions. We have another question related to education. So
Right.
the question is, some colleges, one of the top colleges in fact, have schools which offer data science as an interdisciplinary major for bachelor's programs. Should I go for it if I am someone who is interested in incorporating data science and economics?
Can I just clarify? So these are the economics programs, right? And they offer these courses in data science, right? Is that true?
I think this is the question. So if the participants can raise their hands, you can ask your question.
So if I understood the question correctly, when you are in your economics program and there is an opportunity for data science, you can definitely go to that course, and you will take advantage of that course as well. But if you have a lot of money, you can do that. But in my own view, and in view of my partners and colleagues who also work for Facebook, for Google, for Microsoft, for very huge companies that are included in the Fortune 500 list. So their advice would be not to spend so much money on those courses, but rather to spend money on your essential courses like economics, microeconomics, macroeconomics, mathematics. Mathematics is a very important thing here, right? So if you want to study data science, first of all, you have to understand what's going on in mathematics, right? In probability theory, in statistics. You have to, you have to be very proficient with distributions, like normal distribution, t-statistic, blah 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 blah. So these kind of stuff, I would suggest spending money if you're choosing and identifying a trade-off between among courses in your program. I would suggest you to, go for those subjects, right? Because data science is not something that is incomprehensible if you just do it at your own during your self-study. You can there are a plethora of courses outside on the internet, like Coursera, Udemy, so on and so forth, that you can actually attend and listen to and do some tasks that are assigned there that are way cheaper than the courses in the universities. So this is something that I would suggest you to do. Thank you.
Thank you very much. We have a couple of questions related to labor markets. So
Right.
Participants, yes, if you don't mind, I will unmute your microphone so you can ask your questions. So Darpan, Tomas, and Emils, you have particular questions on labor markets, and also Gaurav. So please, if you don't mind, I will let you speak. So Darpan, will you ask your question?
Hello. Thank you, sir, for the wonderful presentation. So my question was, how is the labor market for like data scientists in the field of consulting and financial services?
Sure. Let me open this presentation. This slide of the presentation. You'll see I've divided the roles, the levels by levels. First of all, well, actually, this is a mistake. Don't pay attention to this column, but look at this. So when you talk about consulting, pretty much these are the distributions of salaries for people lately in 2019. So these are the 2019 data, but from the United States. I'm not talking about the rest of the world, because getting data from the rest of the world is a very different task. But I'm talking about the United States. If you are considering something in the United States, and the average annual salary in the United States ranges from $40,000 to $60,000, this is something as you can compare to the average overall. And in consulting, you will see that the salary ranges from $70,000 to $75,000. This is the 2019 data. So is this something that might be an answer for your question?
Yes, sir. Thank you so much for that. But I do have one follow-up question. So let's assume a person gets into like data scientist as a data scientist role in one of the consulting firms. How could you project like the career progress, or let's say how could he or she like climb up the ladders through the data science field in
Well, you see, data science is not something, it's not an area of expertise that a firm can focus on, right? So data science is just a tool, right? So whether or not you are in certain area, consulting, advertising, or some consulting firms, for instance, McKinsey, BCG, they have different consulting roles in different areas, like mining consulting, right? Managerial consulting, or financial consulting, right? So these kind of things are very different from what I'm talking about, right? Data science is used everywhere. So when you are working, for instance, for a consulting firm as a very entry-level consultant in financial services, for instance, you're consulting banks, commercial banks, hedge funds, or even some individuals as to how they can manage their wealth, data science comes in very handy. But it certainly helps you grow, and it helps you grow fast in your career if you want to concentrate on consulting financial services. But it does not necessarily constrain you from consulting in other fields, right? So it does not constrain you from anything, right? If you know data science is everywhere the same. You rename the variables, right? So you have a data set, for instance, for the last 10 years, Apple's sales, operating expenses, for instance, capital expenditures, so on and so forth. But again, when you go from financial consulting to, let's say, biotech consulting, you will have the same nature of the data. It's just the names of the variables are different. So again, data science is a sufficient condition for every role, wherever you want to go. Okay.
Thank you. We have the next question from Gaurav Palod.
Yeah, thank you. So my question was, I was actually pretty interested in topology. I've done a little maths in that. So could you give an example or any particular topic about topology which I could read further on related to this economics part?
In topology, you see, I'm not suggesting you go through everything in topology, especially when it comes to geometry, right? But optimization, complex numbers, so on and so forth in topology are very useful. So you can work in that. But overall, topology is very useful in everything in economics, because when you create this new in macroeconomics, for instance, when you create these models, new Keynesian model, real business cycle models, so on and so forth, when you work in these models, you'll have to prove certain things that are very complex, and they are not explained in a very straightforward, common way that you are that you're used to, for instance, in your just mathematical analysis course. So topology comes in handy, very handy there. But there is no certain recommendation as to what field to study in topology. Topology overall is very useful. Okay.
Okay. Just a small question to add on to that. Do you have any book recommendations on data science or economics, or books on both data science and economics, which would be helpful?
Sure. Let me. I have this list of books that I find very useful in getting acquainted with and familiarizing yourself, and sometimes memorizing the whole book from every page of the book, right? So sometimes this also helps, because some of those books are very useful. I can share the list of those books if you can, if we can follow up with this. I will, let me write my email here if it's appropriate. Asel, is it appropriate to write my email here?
Yeah, sure, you can write it.
So please write me at my email, and I will send you my recommendations as well as some papers that I find very useful. Okay. So here.
Okay. Thanks a lot. Yeah.
Mm-hmm. Thank you. We have the next question from Tomas. Tomas?
Hey, firstly, I would like to thank you for this great lecture. My question is about how to look for research assistance opportunities abroad, in universities abroad, while I am an undergraduate student. I'm already a research assistant of a professor of mine here in Brazil, where I come from. But I would like to know if there is opportunities like summer internships in academia or this kind of thing.
Sure. The best thing is to first answer the question, where do you want to go, right, in your career? If you're pursuing your an academic career, you want to go forward for a PhD degree, for instance, and become a professor at a certain point in time, you will definitely need to look for universities. But then again, if you want to earn money and very huge amounts of money and go for consulting or business or private sector, you will definitely need to go look up some companies. And I will follow up with these companies and universities later on. Just let me have a overall view. Also, the third field, and lately it's very popular among students that are graduating from schools, especially from Harvard, MIT, all those Northeastern University in New England and Ivy League schools. They want to go further on for NGOs, non-government organizations, like I don't know, Transparency International, for instance, or United Nations, or the World Bank, or the IMF, International Monetary Fund. So basically, what you want to do is to go on the websites of those firms, entities, schools, and look up for opportunities there. Because at schools, for instance, if you want to become a professor, you will have to familiarize yourself with papers of certain professors that you want to study on, right? Because you will definitely you will come up with a certain research interest, and you will look up, or for instance in Google, you will Google certain very prominent professors that are working on these issues right now at Harvard, for instance, or in Boston University, or MIT, or Columbia, or University of Chicago, or so on and so forth. And you just, so at those websites, there are these faculty pages that offer their emails, and you can actually shoot an email to them, and they normally they answer, right? And they can actually arrange an internship for you, or assistantship, or a fellowship program for you during your summertime, for instance. If you want to go to a private sector, just go on to Fortune 500 list and just go on to these these companies' websites, and just click on the career section of these websites and look for openings, and just email them. And if it's possible, you can also call them and ask for opportunities for summer internships, right? NGOs like IMF, the World Bank, the Asian Development Bank, and other very prominent international organizations and international financial institutions, they regularly throughout the year, well, this year they didn't do that because of this pandemic, and the crisis is all out there. But normally these firms regularly organize this internship session on-site and outside. For instance, you can fly to the United States, to Washington, and go to the World Bank headquarters and work, pass an internship there, or you can actually sign up for the internship for the World Bank at some other emerging market or developing country everywhere in the world. So basically go on and surf those websites and apply for those programs there.
Thank you, Gaziz. I think this was a comprehensive answer. The next question we have from Emil, also related to getting a job in the industry. Emil, will you ask your question? Okay, I think we have some technical issues, so I will read just his question. So what are the main things that we just start in university should do eventually to get a job in the industry?
Apart from hard skills, technical skills, by technical skills, I mean getting A's in all your courses in economics and mathematics, like probability theory, linear algebra, so on and so forth. So basically, apart from your GPA, you'll have to develop your soft skills, right? So you have to, you have to develop presentation skills, visualization skills. So you'll definitely need to attend classes on so there are certain social study classes, right, or elective courses that offer you presentation, visualization skills, and communication skills, negotiation skills, so on and so forth. So these things I would suggest doing as well, and do not underestimate those skills, because at the end of the day, when an employer sees two people, with one with very hard, very good, very solid technical skills, but he's not able or she is not able to communicate herself or himself, to prepare presentation, so on and so forth. And on the other hand, as a person who is able to present himself or herself, do a very beautiful, very informative marketing material, for instance, but lacks some sort of modeling skills, most of the time employers will choose the latter one, because technical skills are something that can be more easily developed in a certain period of time. You just need to go over a textbook or run a certain model once, and you will, by acquainting yourself with the procedure, you can do the technical stuff on your own. But soft skills are something that are developed over time, not over a certain task, right? So this is something that I would suggest you to do.
Thank you very much. We have another question from Manoj. As you said at the beginning, your journey to Harvard. Can you tell us about abroad study, prerequisites to university, recommendations to students who are applying in the university, or anything more that will be helpful?
Sure, absolutely. My experience, well, you see, I would not base my recommendation based on my experience, because I'm not that good, right? I'm just an average student. I was an average applicant there, but there was a certain level of luck there when I applied and got admitted to the school, right? But from time to time, it was 10 years ago, and as time passes, the requirements are becoming very stricter and stricter. Normally, 10 years ago, when you applied to a graduate study, even undergraduate study, but mostly to the graduate study at Harvard University, it would require you to have a certain amount of math skills, like the real analysis classes with a grade of no less than A-, for instance. Sometimes probability theory classes, differential equations classes, but nowadays they are must, right? So when it was preferential 10 years ago, now it became a must, a mandatory requirement, right? So you'll have to, during your undergraduate studies, you'll have to pass those classes, and as much mathematics as you can, actually. So if you're able to attend math classes, elect certain courses from the math department, just do as much as you can, and get no minimum than A-, no less than A-, okay? So these are the things that are required, because competition is very fierce here nowadays. We have a lot of applicants. When you analyze, as a Harvard alumni, I just analyzed the admissions last year to Harvard, and there were roughly 50,000 applications to Harvard to graduate study. I'm not talking about undergraduate, because the numbers are even higher, but at a graduate study, 50,000 people applied, and half of them came from two countries in the world, India and China. So the competition is very fierce, because students, applicants from India and China are very, very competitive. So if you are applying to these schools, you'll have to just get as much mathematics as you can. That is the first thing. Then you have to come up with a statement, with an idea, with your story. how and why you decided to attend to this school. This is something that takes the longest in your application process, because you have to prove to the admission committee that you are ambitious, but yet pragmatic. You know your abilities. The choice of your career is very, very conscious. You're not coming to this field just yesterday, so on and so forth. And the third thing that are very important in making the decision is your recommenders. If please try to get acquainted yourself with as much as much prominent professors as you can. You can, again, if you want to do that in long term, just apply to internships at some of these schools, Harvard universities, and so on and so forth. They are free of charge. They don't pay you money, but at summertime, because most people are out of school, professors will still need somebody who can help them in their research, and you can do that for them. And once you do this, especially in research and academic endeavor, right, from the academic side, recommendations from professors, from those you did research with, are very, very, very valuable to the admission committees. So do that as well.
Thank you. We have another question from Nista, and I believe this will be the last question for today.
Okay.
First of all, thank you very much, sir, for the session. My question is, as someone who does not know much computing, because I do not even study it in high school as well, if I want to study econometrics or data science in the future, what would be my first step towards it?
Can you repeat your last part of the question? What?
Okay. So I have not studied much of computing and all of that. Even in high school, I did not study computer science. So if I want to get into data science or econometrics in the future, what would be the first steps that I could take from now on to prepare or to?
Right.
Yeah.
Right. So if you want to study econometrics, there's no computing skills requirement. I mean, computer science requirement. So basically, econometrics is built upon statistics and mathematics. So if you want to do econometrics, you'll have to study statistics, statistical inference, optimization, calculus, integrals, derivatives, so on and so forth. So these kind of stuff are very mandatory for econometrics, but nothing related to Python or Java or some other computer programming language, right? But if you want to do data science, I would suggest, as I suggested in my presentation, I would suggest starting with Python. You can apply, you can create your account at Udemy, for instance, or Coursera, or some other Khan Academy, for instance, or some other online school. And the courses are very cheap there. Most of the time, the courses do not exceed $10 per course. So you can actually attend those courses, and they explain a lot of stuff. They explain how to install the software, how to tune it for your computer. They explain you the concepts of the programming, like loops. How can you declare variables? How can you create data sets? How can you compute? So everything that's actually, programming is not very different from Excel, actually. The only difference is that Excel does not require you to write stuff, because most of the time things are there as buttons, right, on the ribbon, on the Excel ribbon. But in the programming, you just have to do the same thing as you do informally in Excel, but writing your commands. And the only thing that you will need to know is how to communicate your tasks to the computer, and that's it. And those courses are very best at those things, right? They will offer you, without making you engaged in a lot of literature. They will just cut the most important thing for you and present it to you in a couple of hours of videos, right? So do that, and start from Python, because it's the simplest language out there in the world. Once you comprehend yourself and familiarize yourself, and you get proficient in Python, you can go on and study JavaScript, Java for visualization, and you can study SQL for database management, because most of the time you will then encounter very huge data sets that will take a lot of time to compute, right? And your computer would not be sufficient to operate those data. It will take time, for instance, right? Hours and days and weeks for your computer. And something, and in these cases, you will need to address servers like Amazon Web Services, right? Google servers, so on and so forth. So in order to be able to work in those environments, you'll have to study SQL. And these things will come later. And I would suggest you to start with Python. Okay.
Thank you.
Yeah, no problem.
Yes, thank you very much for your interesting questions. If you don't have any other questions, so we will conclude our session. Thank you, Gaziz, very much for your presentation. It was very useful, and I hope our participants will find their journey to data scientists and econometrics.
Thank you, Asel. Thank you, students. I'm really glad you're having me tonight. And also, let me again write down in the chat my email. So if you guys have questions, please, or some requests, please do not hesitate to email me. I'll get in contact and help you out, guys. Okay.
Mm-hmm. Yes, Gaziz, thank you very much. Dear participants, just a kind reminder that in 1 hour we are starting our closing and awards ceremony. So stay tuned. Thank you.
Thank you. Bye.
Bye.